So like I said, postulate is an accepted statement of fact. We're going to talk a few postulates that are going to apply to what you do today in the lesson. The first one is through any blank points, there's exactly one line. And I want you guys to guess if you can come up with what number should go there. So how many points do you think you need in order to make a line? 2, right? We said when you name a line, you use 2 letters. Same thing, in order for you to have a point here and a point here, you can always draw a line through those 2 points. So through any 2 points, there is exactly one line. Okay? That would be something like this, right? If I have a point here and a point here, the only line I can draw through those 2 points is that line. Okay, so through any 2 points, there will be exactly one line. Could you say the opposite of that? What's called a converse. We'll get more into converses lately. But could you say through any one line, there's exactly 2 points? No, right? A line is made up of just infinite number of points. So you can't say the reverse of it, but you can say through any 2 points, there's exactly one line. Okay, another term for you, intersection. If you think about driving, how many of you are driving? It's fun, right? Not a lot of you yet. An intersection when you're driving is, you know, one road's going this way, one road is going that way. They meet right here. That's an intersection, okay? So it's the set of points that 2 or more figures have in common. Where are they meeting up? Where is their intersection? You're going to see that in this postulate 1, 2. One thing to note, I will never ask you for these numbers, like 1, 1, 1, 2. I will never use them. I will never ask you for them. It's just a reference point for us right now, so I put them in there. You don't need to worry about them. Please don't spend time trying to memorize them, okay? The theorem you need to know. The numbers you do not. So postulate 1, 2 says if 2 distinct lines, distinct meaning different. So you can't have 2 lines on top of each other, then they become the same line. But if 2 different lines intersect, they will intersect in exactly how many points? Yes, 1 point, right? If I have a line here and another line here, their only place of intersection is that 1 point, okay? We'll call it point A for now. So they will intersect in exactly 1 point. That is not a cute one. All right, so now this one has a picture with it. There's actually, this is on page 30 in your book. Your book is such a beautiful thing in that it's able to be manipulated. So if you want to go into your book at some point and take a look at this, it's rotating in the book. I just took a screenshot of where I wanted it. But you can kind of get a better visual of like, how is this laid out? So if you want to take a look at that later, go for it. It's on page 30. But this one says if 2 distinct planes, so right now I have a blue plane and like a yellow, orangey yellow plane. When they intersect, when they meet, their intersection is exactly 1 what? Can you see where their intersection is? What? What did you say?
Thing.
1 thing. Yes, it is 1 thing. It's 1 line, right. So they will intersect in exactly 1 line, okay? Keeping in mind that a line, like line ST here, looks like that. Is their intersection that? Do you remember what that is? With just the bar over top? That's a segment. Would you say their intersection is a segment? It's not, okay? It's going to be tempting in like quizzes and tests to want to say segment instead of line because it's really hard to draw planes, right? What is true of planes? They go on forever, right? Forever this way, forever that way. So when 2 planes intersect, their intersection goes on forever, okay? So when 2 planes are intersecting, you want to make sure it's a line, not a segment, because the line will just keep going, okay? All right. I'm just going to show you like a physical example of this just so you kind of get a feel for it. And I feel like it'll help you remember it later on. If you think of the floor as a plane, right? And then you think of this wall as a plane, you got to pretend that it keeps going through the window because that moves over. But if you think of this plane and this plane down here, and then you think about where they meet up, their meeting point is this corner right here, right? It's just a line that runs the whole length of the floor and the wall. So think about that when you're trying to come up with what is the intersection of something. Give yourself a visual. The wall and the floor, they meet at a line, okay? How are we doing so far? Questions on any of that? Okay. Example 3 here. We're going to do a couple questions about planes and their intersections. So the first one says, name the intersection of plane ADC and plane BFG. And I'm just going to do a little bit of color coding here just so you can distinguish which is which. What is plane ADC in that figure? Is it left, right, top, bottom, front, back? What's ADC? It's the top plane, okay? So where A, D, and C are, that would be this plane. So they're saying, what's the intersection of that plane? And then BFG, which plane is that?
Right.
That's the right side of the figure, so that would be this plane. Okay, your job is to figure out their intersection. What is the intersection of two planes? Always. A line. So you're looking for which line is the intersection of those two planes. Can anyone tell me what that should be? Line BC, right? It's this one right here. And it keeps going, even though it doesn't look like it keeps going. It's a plane and a plane, so their intersection is a line. So we would say line BC. So just make sure you put the arrows over top. All right. Then we're going to ditch this. And it says name two planes that intersect in EF. So if you look at your picture right now, EF is here. Okay, can you tell me two planes that are meeting up at that line? Which two? ABE and GHE, yes. So lots of ways to name a plane, right? You could call this bottom one EFGH, or you can call it EFG or HEF. I don't remember exactly what letters you used, I'm sorry. But we would say plane, I'll just say EFGH, but you can use any three of those four, okay? So plane EFGH, and then what's the other one? The other plane that meets at EF there. AB. Okay, and here's the thing. ABEF, yes. When you name a plane, you want to go in like clockwise or counterclockwise order. So in this case, we would say if it's AB, we'd have to go FE, just so that it has that flow, right? It's going one direction or the other. So plane EFGH and plane, oops, I didn't change back to my pen. So ABFE. Okay, any questions on that? Yeah,
So like
Carson.
if it's saying like name a plane, we don't like put the line on top, we just
You put the word plane in front of it, yeah, when you're naming it. It's a great question. Any other questions? All right, moving right along. So postulate 1.4, this is my favorite one. I don't know why, it just is. Says through any blank non-collinear points, there's exactly one plane. And I kind of touched on this yesterday and this morning even a little bit already. without actually giving you the postulate. Does anyone know the number that should go there? How many points will always make exactly one plane? 3. So through any 3, and here's the key word, non-collinear. What is non-collinear? Not in a straight line, okay? So here's what I want you to do. Take your fingers and don't put them in a straight line, okay? You have to off-kilter them somehow and see if there's any way that you could, well, that's not true. See if you can get them to lie flat on your desk, like that. So every finger touching your desk with 3 fingers. Every one of you should be able to say yes, right? I can get all 3 fingers to touch. They won't necessarily stand straight up, but you can get all 3 of your fingers to touch your desktop, okay? Because through any 3 points, there's exactly one plane. Any photographers in here? A few of you? Okay, so for those of you that like to do photography, if you want to take an actual like still shot of something, what's a good tool to use? A tripod, okay? Notice that photographers don't use a quad pod, we'll call it, right? You would not put a 4-legged thing down to take a picture. They use a tripod because they will always be able to get a flat surface with their tripod, okay? I always think it would make a whole lot more sense to make stools that are 3-legged, but I guess it just doesn't feel as secure for people because if you've noticed, when you sit on these stools in science class or whatever, and one of the legs gets slightly off kilter, you wobble, right? If it was a 3-legged stool, you wouldn't wobble. Now, if one got a little shorter, you would lean, so that's unfortunate, but you would not wobble because you could get all 3 of those legs touching the ground at the same time. There's always going to be a plane through 3, okay? So that is postulate 1-4. And what we're going to do is go through this example 4. Again, I'm going to do a lot of shading, but I'm going to like shade, and then I'm going to erase and do the second one, erase, do the next one. So however you want to do that with your notes is totally fine, or if you want to copy that picture before you shade it and like make a copy of it so you have several to work off of, that's fine too. But example 4 here, it says, what plane contains points N, P, and Q? So we know there's going to be a plane because there's 3 points, okay? There's got to be a plane that goes through them. N, P, and Q, which plane is that? So give me again like top, bottom, left, right, front, back. Which plane is that in this figure? That's the bottom, N, P, Q. So here's N, here's P, here's Q. So our plane would be this bottom one here. So you can just write the bottom of our figure. You know what, I'll just change colors and see how that works. Okay, so then it says, what plane contains points J, M, and Q? This one requires a little more depth of thought. It's not the back one. So here's J, here's M, here's Q. Can you tell me, before you try to tell me like about the plane, what the 4th point that would kind of be associated with those 3 would be? Not L, it'd be P, okay? So what's happening with this plane? It's cutting through the figure, right? So your plane is actually going to be, if we connect those points, it's gonna look like this. You can kind of think of it as my Kleenex box here. Right? They gave us 3 points. They gave us these 2 up here and 1 on the bottom. Well, this one's got to be the one related to it. So our plane is cutting this Kleenex box diagonally in half. Does that make sense? So I'm just going to write the red one here. And then what plane contains points M, L, and Q? So here's M, here's L, here's Q. Which plane is that going to be? That's your back plane. Notice whenever there's dotted lines, like I said before, those are ones you're not seeing. So that's how we know that's the back and not the front, okay? Any questions on that? All right, that's your lesson.